So we're solving for x inside of a log again. And first thing we need to try to do is get things to a single logarithm. Now, the first equation has 3 logarithms. On the right-hand side, I have a log plus a log. I can combine that to a single logarithm by multiplying, so it'll be x plus 6 times by x minus 1. This question does have a shortcut. So I'm going to do the shortcut in blue and show it to you first. And then I'll show you what we would do if we kept going in regular. Okay? With the shortcut, and this shortcut only works if you have a log equal to a log. You can do one of these. So, does it make sense if a log equals a log and they're the same, that the insides would have to be the same? Does that make sense? Just using logic? Log of blah equals log of blah. The blah equals a blah. And so now this is algebra. How do we solve this? Well, I could expand this side to be x squared plus 5x minus 6. Put my quadratic equation. I solve a quadratic equation by moving everything over to one side. And I can factor x minus 3, x plus 2, so I get 2 answers. X equals 3 and x equals negative 2. And this is where students often forget the very last step in solving for a log. You are so excited you found answers, you just stop and go on. But you always have to check to see if those answers work. So we go back to our original equation, which is right here at the top. If I plug in 3, will I ever take the log of a negative number? 18 is positive, 9 is positive, 2 is positive. This one works. If I plug in negative 2, right away, 6 times negative 2 is negative. That's bad. I put an x through that one. That one's not possible. Careful, because we've had 2 examples. And in both examples, the negative answers haven't worked and the positive answers have worked. That doesn't always happen. I can make a question with 2 positive answers where they both don't work. I can make a question with 2 negative answers where they both work. I can make a question with 1 negative and 1 positive, and the negative one works and the positive one doesn't. You always have to check the original equation to make sure you don't take the logarithm of a negative number. And I'll give you some examples later where the opposite works. Okay? So this is the shortcut by recognizing if I have a log equals a log, I could do that. If you want to use the regular method, and I'll do this on this side, I'll split it up right here. The regular method says we need to get a single logarithm. And I combine the right-hand side, and I have a single log on the right-hand side and a single log on the left-hand side, but my equation still has 2 logarithms. If I wanted to combine them, I would have to move them both to the same side. I could do that by subtracting log 6x on both sides. And if I subtracted log 6x on both sides, what does that tell me? Do I have a log law for subtracting? Yes. I could combine this to a single logarithm. But the minus 6x means we divide, right? So our log law for subtracting, if you're subtracting 2 logarithms, you can divide the arguments inside of one logarithm. Oh, that's what you meant. Yes, you're right. Thank you. I thought you meant that this should be a minus on the bottom. This is a minus. Thank you. Minus, minus. Perfect. At this point, we have a single logarithm. Once you get a single logarithm, you use the definition, you change it to exponential form. What's the base? 10, right? Common log, when it's not written, the base is 10. What's the exponent? 0 equals the answer. And 10 to the 0 is equal to 1. And you have a rational equation to solve. How do you solve a rational equation? Get rid of the fraction. I can multiply both sides by 6x, right? If I multiplied both sides by 6x, the 6x's on this side would simplify, and I would get 6x equals. Can you see why the shortcut is nice? We just got to where we started. And then from here, it's the same. Both methods are perfectly fine. Of course, if you have a log equal to log, the shortcut is nice, because you can save yourself a lot of time. So let's look at part B. We want to get things to a single logarithm and then change to exponential form. Do I have a single log? No. I have two of them. Can I combine these? Yes. A log plus a log. Multiply. Once you have a single logarithm, then you can use the definition. And this, like, it's amazing. This next step is always forgotten. You can remember to get a single logarithm, and then you look at it, and this is where, if you've ever had those moments where you blank on a test, this is where it's going to be. You're going to forget this next step. The reason you're going to forget this next step, right, changing to exponential form, the base is 2, the exponent is 3, is because you're using a definition. The definition of a logarithm, what a logarithm is in exponential form, and your next step looks so different than your previous step. Like, they almost don't, you're like, where did that come from? And especially if you didn't know logarithms, you would look and I say, I don't understand the mathematics at all here. And that's why it's so easy to forget this step. But once that step is done, well, what kind of equation do we have here? Oh, it's a quadratic equation. I know how to solve quadratic equations. Make one side equal to 0, factor, or use my quadratic formula. Luckily, in this case, this one factors. And at this moment, I'm going to get mad at the textbook because they've, well, we'll see. Did they do it again? Did they do it again that the negative one doesn't work and the positive one works? Because then I would be mad. Try negative 4 in the original equation. Does that make us take a log of a negative number? Yes. Try 2. Does it make us take a log of a negative number? Or 0? No. So they did it again. They made the positive one work and the negative one not. That's not always the case. In fact, once on an exam, maybe about 5 or 6 years ago, the very first question on the exam was a log equation, and none of the answers worked. So you're starting your exam, you're like, okay, 3 hours. Here we go. I'm pumped. I'm going to do well. I'm ready for this exam. Question number 1, you put all that work in, and then you have to write no solution. Turn the page, all your confidence is shot. You're like, I just screwed up on the first question. I suck at math, and I've got 2 hours and 50 minutes more misery to go. And they did that. I thought that was a very mean first question, to have the first question have no solution. But I guess it's possible. Okay, questions for this one are 11 and 13.